Good day all. We are looking at calculus, and under calculus we have two aspects, which are differentiation and integration. But we will be taking a look at differentiation, and then we'll move on to integration later on. We have differentiation to actually mean or talk about the rates of change. Rates of change. In the coordinate geometry that we must have earlier learned about, we have the calculation on gradient. Calculation on gradient deals with rate of change of y to the rate of change of x. In other words, the distance in the change in distance moved along the y-axis, and with respect to the change moved in the distance along the x-axis. That is what we mean by rates of change. But we are going to leave out all those stories about the rates of change, and we move on to the formula straight away and how to apply the formula, because we want to also restrict ourselves to differentiation of polynomials. Only polynomials we'll be looking at. We have differentiation of trigonometric functions. We have others like parametric functions, but we are going to restrict ourselves to polynomials only. And that is the simple aspect of it that we will restrict ourselves to. And other formulas that applies to differentiation, we will want to leave those out and restrict ourselves to the very simple ones that involves the differentiation of simple quadratic expressions. All right, so we have earlier said that the differentiation is actually talking about rates of change. And I mentioned the calculation of gradient in coordinate geometry, whose formula we can see right here. You can do this calculation for gradient when you have the 2 points given, such as x1, y1 and x2, y2. You can use that to find the gradient. Now, what is the relationship between gradient and differentiation? Differentiation deals with rate of change. Gradient is also rate of change. And differentiation makes use of a symbol which we will be unveiling shortly. And that symbol is called differential coefficient. It is used in calculating the gradient of a curve. It is used in calculating the gradient of a curve. So instead of going about the rigorous means of drawing the graph and then working out the gradient by drawing a tangent to the curve and then eventually finding the gradient that applies to a particular point on the curve, we can easily work out the gradient using the differential coefficient for the given relation. So let's move straight to the point and then ignore all of that. Now we have in general that if we have a function y given as x raised to power n, so I have a function y given as x raised to power n, y equal to x raised to power n is any polynomial. It could be quadratic. We can also have linear anyway. We can have powers greater than 2. We can have powers greater than 3. We can have powers greater than I can have power above 2, 3, 4, and so on. So in summary, all of that will have categorized as polynomials. So if I have a function y equal to x raised to power n, then I have the differential of y as dy dx. I've read this as dy dx. The notation dy dx means differentiating y with respect to x. Differentiating y with respect to x. It also means the same thing as finding the derivative of y with respect to the variable x. It means this, the y dx, means finding the derivative of y with respect to x. What if this y was not y, if this was actually p, and they put x here? Then we can have dp dx. We can have dp dx. What does it mean? It means differentiating the function p with respect to x. But in this case, we'll be working with y and then differentiating with respect to x. You can also be given the function y equal to t raised power n, and then asked to find dy dt. So you'll be differentiating y with respect to t. But if you are given y equal to x and then you are asked to find the derivative of y with respect to s is the same thing as differentiating y with respect to x, differentiating y with respect to s. So it is just a change in language, which means the same thing. Find the derivative of y with respect to s is the same thing as saying differentiate y with respect to x. So this dy dx, please, it is not dy divided by dx. It is a function. It is a function. We call this a gradient function. It is a formula. It is a symbol that means an operation. It is a symbol that means an operation. It is a symbol that means we are finding the derivative of y with respect to x. It is not dy divided by dx. It is written dy dx, read dy dx. So what is the definition of this operation? It means use the power of the x. The power of the x in this case is n. Multiply the function from behind. So I'm going to use the n to multiply my x. So that will be nx. Then I'll reduce the power of the x by 1. I'll come again. N times x from behind. Then when you are writing the power of the x, you write the power minus 1. In other words, you reduce the power by 1. So n times x raised to power n minus 1 is the differential or the derivative of y equal to x raised to power n. Now, it is also possible that we have a function y equal to ax raised to power n. In other words, a stands for a constant. It can stand for any number. It can stand for 2, 3, 4, 5, 6, 7, 8, 9, whatever number that is representing, that number is a constant. So if you have a constant, for example, y equal to 2x squared, y equal to 3x squared, that constant will be multiplying, will be taking part in our multiplication when we are going to find the differential of y. So in this case, now you're going to have the power of the n, the rule still remains the same, the power of the n multiplying from behind. So we have n times a, that will be an, then x raised to power n minus 1. I'll come again. N times a, then x raised to power n minus 1. Remember that whenever you multiply the entire by the power of n, you deduct 1 from the power when you're going to write x down. You don't write x with the power remaining the same as in the initial. You deduct 1 or you reduce the power by 1. So we have n. So in this case now we can also say that the coefficient of x here is 1. So that we have n times 1, that gives us n. So we have nx, x raised to power minus x raised to power n minus 1. Now let us take some examples. We have find the derivative of the following functions. Y equal to x raised to power 5, y equal to x raised to power 7, y equal to x raised to power minus 3, y equal to x raised to power minus 4. So we're going to apply this first one. It is the same operation. It is the same rule, it's the same operation. It's just that we have the coefficient of this one to be 1 and then the coefficient of this one to be a constant that is greater than 1. So that's just the difference. So I've decided to solve some problems here whose coefficient of the x or the x variable is always going to be 1. So how do we apply that? We have, if y equal to x raised to power 5, then dy dx, which is the derivative of y with respect to s, is 5 times x, then raised to power 5 minus 1. So that gives us dy dx equal to 5 raised to power 4. If y equal to x raised to power 7, dy dx will be 7 times x raised to power 7 minus 1. And then that gives us dy dx as 7 x raised to power 6. If y equal to x raised to power minus 3, dy dx will be minus 3 times x raised to power minus 3 minus 1. and that gives us dy dx as minus 3 x raised to the power minus 4. If y equal to x raised to the power minus 4, then we have minus 4 times x raised to the power minus 4 minus 1. And our final answer you have there. All right. Recalling our rules again, we're going to take another set of examples that will make use of this other one, whereby we have a constant with the x term. Remember, we are working on differentiation of polynomials. So we have an example. If y equals to 2x raised to the power 4, and we are asked to find dy dx, what would that be? Our dy dx would be 4 times 2x raised to the power 4 minus 1. And finally, that will give us 8x raised to the power 3. Find the derivative of the function. Find the derivative of the function y equals 4x squared minus x minus 5. Now, if you have more than one part of the function, you are going to differentiate each part of that function as long as they all make up a single problem. So I'm going to differentiate this part separately, differentiate this part separately, and differentiate this part separately. So we have that the differential of this will be 2 times 4, that will be 8x. If I deduct 1 from 2, that will be 1. So that will be x raised to the power 1. Now remember that this x here has 1 as its power. So if I bring down the 1 and multiply from behind, I will have 1 times minus 1. So that will be minus 1 x raised to the power 1 minus 1. And that will be 0. So that will be 4x squared minus x. Then if I have 5 here, a constant, the differential of this constant is always going to be 0. If you differentiate just an ordinary number, a constant, the differential will be 0. I'll come back to this problem. Let us go straight to some examples that I solved that actually addresses this in a very simple way. Then we'll come back to this problem. So I'm going to skip all of this and come back later. Now we have this set of examples. Differentiate the following functions with respect to x. So we have y equals 3x raised to the power 5. If y equals 3x raised to the power 5, then dy dx is 5 times 3, that's what you have here, times x raised to the power 5 minus 1. So remember, you multiply the entire with the power of the x from behind, and then when you're writing the x down, you deduct or you reduce the power by 1. So we have 5 minus 1. So that gives us 15x raised to the power 4. I have written all these long steps just to make clear the differentiation, or to make clear how the derivative was gotten. You need not write it out. You can just go from here and then straight to this answer. All right, so we have 3 times 2, that's 6x. And we have 2 times minus 1, that was minus 2x. Then deduct 1 from this 2, you have a 1. So that will be 6x squared minus 2x. You can see the working down here. You can pause the video and take a look at it very well. Now, let's say we have a function y equal to 7. This is called a constant function. When you have a constant, in this case, 7 is just an ordinary number, so it is a constant. We are differentiating a constant. The differential of a constant is always going to be 0. Now, I've done this very lengthy write-up here to try and explain how this becomes 0. Now, y equal to 7 is the same thing as y equal to 7 times x raised to the power 0. Remember, anything raised to the power 0 is always 1. So 7x raised to the power 0 means 7 times 1. And that gives us back our 7. So I've written y equal to 7 as y equal to 7x raised to the power 0. Now, the differential of y with respect to x in this case would be 0 multiplying 7 times x raised to the power 0, then subtracting 1 from the power. Now, whatever this part is, it doesn't matter what this part is, this part that we have 7 times x by whatever it is. As long as you're multiplying by 0, everything vanishes and turns to 0. So what does it mean if you have a constant as part of your polynomial and you are differentiating that? The differential of that constant is always going to be 0. The differential of that constant is always going to be 0. So in summary, if y equal to 7, then dy dx is equal to 0. We need not write all of that we have up here. Now we have this one, y equal to 9x. The y dx will be 1 is on top of this x. Let's take note of that. So we have 1 times 9. We have 1 times 9x, then 1 minus 1. So 1 minus 1 will be 0. So that gives us x raised to power 0. In this case, anything raised to power 0 is always going to be 1. So 9x raised to power 0 is going to be 9 times 1. So we have 1 times 9 times 1. Eventually, the answer becomes 9. So we have established two things here. First, we said that when you're differentiating a constant, the differential of that constant is going to be 0. Next, what we are establishing here is also if you are differentiating a function that is just having the variable x, just one x, just x raised to power 1, it means that the differential of that function is just going to be the constant, which is the number just multiplying the x. So we have differential of 9x is going to be 9. Differential of 3x is going to be 3. Differential of 4x is going to be 4. Differential of 7x is going to be 7. Differential of minus 3x is going to be minus 3. What about the differential of minus 7? I'm sure you know what that will be. All right, so we have this polynomial now. We have y equal to 6x5 minus 2x squared plus 5. Now the differential of this, that will give us 30x raised to power 4. I've reduced the power by 1. Then we have 2 times minus 2, that will be minus 4. So we have minus 4x, reduce the power by 1, so minus 4x raised to power 1. This is a constant. The differential of this constant is going to be 0. So our final answer is going to be 30x raised to power 4 minus 4x. I initially said I would look at the problem that I skipped earlier on. So I'm going to go back and take a look at that. We'll take a look at that together. Okay, so the question says find the derivative of the function y equal to 4x squared minus x minus 5. The differential of this will be 8x raised to power 1. The differential of this is going to be minus 1. So I'm sure that will be easy for us to understand now. The differential of this is going to be 8x, and the differential of minus is going to be minus 1. So this is a constant, and the differential of that constant is going to be 0. Another example says differentiate y equals x raised to power 4 plus 3x squared minus 5x plus 2 with respect to x. All right, so we already said that you differentiate each of the parts of that particular function. So we have 4x raised to power 3. Differentiate the other parts, we have 6x raised to power 1. And then differentiating minus 5x will give us, I'm sure you know what that will give us. Okay, let's see if that's what you said. All right, so that gives us a minus 5. What about the differential of 2? That is 0. So differential of y equals x to the power 4 plus 3x squared minus 5x plus 2 is going to be 4x cubed plus 6s minus 5. That is the answer. In general, if y is made up of the sum of or difference of any given number of functions, its derivative will be made up of the derivative of each of the functions. Now, let's take a look at this final one. If y equal to a, and I have recalled this general symbol or general formula as we've written in the beginning. Differentiate y equal to 2 over x with respect to x. Now, let's see how this can be solved. We have y equal to 2 over x, which can be written as 2 times 1 over x. And then the 1 over x can be written as x raised to power minus 1. So we have 2 times x raised to power minus 1. That gives us 2x raised to power minus 1. So if I'm differentiating this, what do I have? I have minus 1 multiplying from behind. So that gives us, I want to give it a try. All right, so I hope that what your answer is what we have here. We have minus 1 times 2 from behind, then x raised to power minus 1 minus 1. So the final answer to that is minus 2x raised to power minus 2. So that gives us the solution to that. And that leads us to this final problem. We have if y equal to 2 plus 3x minus 5x squared, we have to find the y dx. Then the y dx is going to be 3 minus 10x. I'm sure you can figure how that is gotten. When we come around again, we're going to be looking at finding the gradient. Remember, I started by talking about finding the gradient. What we have just done in all of this is working out the gradient function. All the derivative we have come up with in these calculations for today means finding the gradient function. I will explain from there in the next meeting what this leads to regarding finding the gradient of a function. Remember, I said this is find the gradient function. We can then move from here in the next meeting to finding the gradient of a function.